Hello everybody, welcome to the next video. Sorry it's a little late coming out. Actually I was upgrading to I'm using a new version of Smart Notebook, so we may run into some minor problems over here, but we should work it out. Interfaces might be a little bit different than they had been previously. So what we're going to talk about is, we're talking about probability, but we haven't really gotten into the nuts and bolts, and this is going to be some of the mathiest stuff we do. Is with equations and other things. So let's get to some definitions. The sample space. When we talk about sample space, this is not about sampling. This is when we talk about probability. Sample space are all possible outcomes. So that's our first definition. And then our probability model is the description of some chance process that consists of two parts: the sample space and the probability for each outcome. So for example, when we roll a die, the possible outcomes are 1, 2, 3, 4, 5, and 6. And the probability of each outcome is 1/6. And now we have a probability model for rolling a die. And so how about, what is the probability model for a chance of rolling two fair six-sided die? One that's red and one that's green. Well, we could do a simulation and do this, but we'd have to roll dice for days to get a good simulation, because there's so many different possible outcomes. We'd have to roll the dice like 10,000 times. And that seems kind of silly, because there is a fixed number of outcomes. There are 36 different outcomes, right? And here are the two different dice, the red die and the green die. Sorry, the green's a little faded here. But basically there are 36 different outcomes. And so our sample space is 36. Since the dice are fair, each outcome is equally likely, so each outcome is 1 out of 36. So the probability of having the red die come up 6 and the green die come up 3 is 1 out of 36. We'll come back to this in a second. But the probability model allows us to look at the probability of any collection of outcomes. So let's talk about, what is my probability of rolling a 3? So what's the probability of that when I add the two dice I get a sum of 3? Well, there is one outcome and there is the other outcome. They're equally likely. So my probability of getting a sum of 3 is 2 out of 36, or 1 out of 18. Sorry, that's a little hard to read. Let's change the color on that. Playing with the new. Where do they come up? Oh, here, over here. There we go. There we go. All right, so your probability is 1 out of 18. So an event is a collection of any outcomes for some chance process. That is, the event is a subset of the sample space. And we always tend to use capital letters. So we would say A is a sum of 3, so the probability of A equals 1 out of 18. And we would define each one. So how about if we defined A as the sum is 5? And let's do this, hold on. And so we would say, since each outcome has a probability 1 out of 36, and there are 4 different outcomes that will give us a 5, right? You got the 1 and the 4, the 2 and the 3, the 3 and the 2, and the 4 and the 1, then the probability is 4 out of 36, or 1 out of 9. So suppose the probability of event B is defined as the sum is not 5. So what is the probability of B? Well, remember that the probability of something happening and something not happening are always going to add up to 1. And this is a big deal, is that something either happens or it doesn't, and so the probability will always, sum will be 1. So the probability of B would be 1 minus 436. And so the probability of something not happening is always 1 minus the probability of it happening, because probabilities of something happening and something not happening always add up to 1. All probabilities must obey the following rules. The probability of any event is a number between 0 and 1. All possible outcomes together must have probabilities whose sum is 1. And this is a big one. This is going to appear on the AP exam. They'll say, is this a valid probability model? And here are all possible outcomes. And if the outcomes don't add up to 1, it is not a valid probability model. If all outcomes in the sample process are equally likely, then the probability that event A occurs can be found using the formula probability of A equals, sorry, this just got cut out, probability of A equals number of times A occurs divided by the sample space, which is all possible outcomes. If the probability that an event does not occur, so the probability of not A is 1 minus the probability of A. And we're going to learn a special term for that here in a second. If two events have no outcome in common, then the probability that either occurs is the sum of their due. So the probability of A or B equals the probability of A plus the probability of B. But the big thing here is that, and we'll learn, if they have no outcomes in common. So the probability of rolling a 7 and a 5, or a 5, is you would add those two probabilities together, because you cannot roll both a 7 and a 5. And two events are mutually exclusive if they have no outcomes in common, and so can never occur at the same time. And that's another big one, is that, I'm sorry, there's some stuff that was supposed to be posted in that last one. It's not coming up with my new smartboards, and that's why we're seeing that. So let's go back and say this. We'll put this in. Oh, it's here. So for any event, here's the summation again. For any event, probability of A is always between 0 and 1. Here is that formula again. The number of outcomes corresponding to an event A divided by the total outcomes in the sample space. The probability of S is 1, because the probability of getting an outcome is 1. If you roll the dice, you're going to get a roll of the dice. This right here, the probability AC basically is the same as the probability of not A, and it's just a fancy way of writing that. And that's what's referred to as the complement. The key here is this, you can only use this formula if A and B are mutually exclusive. I know I covered a lot of material, and you're going to want to go back and review this. I would make sure you have well, that's going to be really annoying, but I'll fix that in a second. You want to make sure you have this page down cold. And this page here down cold. Make sure you have all of this and you understand what all of this means. Pause, rewind, do whatever you need to do. But that's it, because there will be a quiz on this stuff next class. See everybody tomorrow.